Let's talk about function notation. Number one, evaluate g of x. G is the name of the function. X is our input. And then 3x is our output. When x is negative 2, so hang on, this is 3 problems. So when x is negative 2, 0, and 5. So for this one right here, it's going to be g of negative 2 equals 3 times negative 2. So this one is negative 6. This one is g of 0 equals 3 times 0, 0. Last but not least, g of 5 is 3 times 5. That's 15. Evaluate r of x, which is x, negative x minus 7, when x is, so same thing. Right here we have r of negative 2 equals negative 2 minus 7. So this is 2 minus 7, or negative 5. Next, we have r of 0. That's negative 0 minus 7. That's just minus 7. And last but not least, r of 5 is negative equals negative 5 minus 7. That's negative 12. B of x, b of negative 2 equals 18 minus 0.5 times 2. Well, if you double 0.5, that's 1. 18 minus 1 is 17. B of 0 equals 18 minus 1/2 times 0. That's 18. And last, we have b of 5 equals 18 minus 1/2 times 5. So 5 halves is 2.5. 18 minus 2.5 is 15.5. Number 4, evaluate n of x. So same kind of thing. N of negative 2 equals negative 1 minus 1/3 times negative 2 plus 1 2/3. Well, you know what? I'm going to do something real quick. We can simplify this because these two are like terms. So really, we should have just negative 1/3 x plus 2/3. Okay, because negative 1 plus 1 2/3 would just be 2/3. Okay, so what that does is, I know it seems silly, but I'm going to erase this just so that I can think through it a little bit faster. Because I look at it this way. I have negative 1/3 times negative 2 plus 2/3. So a negative is positive. So this is just 2/3 plus 2/3. This is 4/3. And what am I supposed to do? Simplest fraction form. So hopefully 4/3 is fine. If not, 1 1/3. Next. N is 0. Well, check it out. If I put 0 right in here, I just get 2/3. And by the way, that's why I did this right here, because I don't have to do this simplifying each time, because it doesn't need to be simplified each time. And then last but not least, we have n of 5. So now I have negative 5/3. And if you're wondering, wait, how? It's because I had negative 1/3 times x, or negative 1/3 times 5, plus 2/3. That's negative 1, because this would be negative 3/3, negative 1. Number 5, let h of x be the percent of U.S. households with internet use x years after 1980. Okay. So this is like 27 years after 1980, so that's the year 2007. Let's see. All right, so there's that one. And nope, not that one. Got to read all the choices. It's that one. 61.7% of U.S. households had internet use in 2007. Cool. This is 1984. So let's see. And then it says K. So that's this one. K% of U.S. households had internet use in 1984. I know that doesn't make a lot of real world sense, but it works because that's K, right? And then that's K. So moving on. 37 would be, let's see, 1980 plus 37 would be 2017. And 30 years would be 2010. And the idea is that in 2017 there was more than in 2010. So there's that one. And last but not least, if we add 17, which would be 1997, and if we add 2001, it is roughly the same as 2009. Yeah. So let's see. That's that one. And if you're like, well, how did I know what these little squigglies were? Well, think about this one. This one is less than. I mean, that's this symbol, a less than symbol. So it's not that one. Moving on. Find the value of x so that the function has the given value. T of x equals 3x, and tx equals 24. Oh, okay. So we just want to know what number do we plug in right there in order to get that. That would be 8. 3 times 8 is 24. How you could solve this is we want to know when 3x equals 8. Sorry, not when 3x equals 8. We want to know when 3x equals 24 because we want to know when t of x is 24. Well, this is t of x. Find the value of x so that the same thing. Okay, so if k of x equals 15, I'm just going to replace this with 15. So when does 15 equal 6x minus 12? Add 12 to get 27. Let's see. Well, I guess I gotta do some math here. 6 times 4, 24. Oh, 4.5. Gotcha. 4.5. Find the value of x. Same thing. Negative 5 equals negative 4/5 x plus 7. Subtract 7 to get negative 12. Multiply by 5, negative 60 equals negative 4x. And I think this is 15. Yeah. By the way, we did one like this in the notes. And if you were like not sure if you were right, what could you do with each of these? Take this and plug it in. Take this and plug it in. Take this and plug it in. So for example, right here where I said, I think it's 15. 15 times negative 4/5, well, that would be negative 12. And negative 12 plus 7 is negative 5. Find the value of x so that f of x equals 7. So what they're saying is f of x equals 7. Y equals 7. Where does y equal 7 on this graph? Well, it's kind of funny. It equals y. Y equals 7 right there. Because that's 1, 2, 3, 4, 5, 6, 7. This will be, all right, 7, we go out, and it is negative 3. That is how. That's the value for x. So when x equals negative 3, y, or f of x, equals 7. Real life, the function d of t equals 300,000 t represents the distance in kilometers that light travels in t seconds. Okay, how far does light travel in 15 seconds? 300k times 15. So I believe that is 1.5 million kilometers. That's pretty fast. The distance from the sun to the earth varies from 91.4 to 94.5 million miles. How long does it take light to travel from the sun to the earth? So this is distance. That is time. So we are trying to find time on this one. So what we're going to do is we have an inequality, and I'm going to kind of let's zoom in, shall we? 91.4 is less than 300,000 t, which is less than, what, 94 and a half. I don't know why I did that. So if we divide by 300,000 on each side, oh, and by the way, this will come up with like a crazy ugly looking decimal if we do it right now, but this is rounded, like actually it's not rounded, it's in decimal form, so really this is 9140000 like that. And this one over here is 9450000 like that. So when you divide by 300,000, I'm going to show you a little trick here. Those zeros all cancel out. So we have 914 divided by 3. And over here, we can just do this. We canceled 5 zeros right here. So let's just cancel 1, 2, 3, 4, 5 here. 945 divided by 3. Yeehaw. So I'm going to do this by hand just real quick. 914, 3. So let's see, that's 90, that's 14, that's 4. 90, 304.6. Round to the nearest tenth, so let's keep going. Oh, so it's 0.6 every time. So we have between 304.7 seconds and, let's do this one real quick, 945 divided by 3 is a little easier. It's 315, I believe. Hang on, let me do it. 9 times 3 is 9. And then, yeah, so 315, 315. So those are your answers right there. Okay, and I've written on top of the next problem, graph the linear function, negative 5x. Okay, well, so you and I, we kind of talked about how, you will need to do a table, x and y, or in this situation, it could be x and f of x. So I'm going to show you this table and how I might construct one, but at the same time, this is in slope-intercept form, so we could graph it in a heartbeat, which is really fast, by the way. So I could plug in 0, and I would get 0. So there's 1. I could plug in 1, and I would get negative 5. So at 1, we have negative 5. I could plug in 2 and get negative 10. 2, negative 10. I could also go backwards. I could do negative 1 and get 5. And I could do negative 2 and get 10. So that's a little off my graph there. And I'm not going to try and make it a straight line. I mean, I'll try. There's the straightest line I'm going to get. So there's my table. I have 5 values and 5 dots on the graph. But like I said, we knew based off slope-intercept form that there was that right there is the y-intercept. And the slope was negative 5, so down 5 over 1, down 5 over 1. Okay. Very similar. Graph the linear function. So we know that it's got a y-intercept of 2. And, okay, now let's talk about that. You might think, I can't do that. It's 6/10, right? 0.6 is really 6/10, which we could reduce to 3/5. And you might ask, why would I reduce it? Well, mainly because I didn't want to rise 6, run 10, even though, check it out, that wasn't that bad. I could rise 3, run 5, perhaps a little easier. Rise 3, run 5, but oh look, we got the same thing either way. So there it is. But again, like I said, technically we are practicing our table here. And I'm going to write it, x and y, x and w of x, and then plug in some numbers. So when x is 0, y is 2, because that's my y-intercept. And you'll notice I like starting with 0, because 0 is easy to calculate. I like 1 next because it's also easy to calculate with. And if you're wondering, how did he get that so fast? 1 times 0.6 is 0.6. 0.6 plus 2, 2.6. And then next is 2, because 2 is easy to calculate with. 2 times 0.6 is 1.2. And here's the reason why I did this still. Because you and I, even though we can graph with the slope-intercept form, we need to be able to come up with individual values. And how do you do that? You pick numbers, and then you plug them in. Graph this function. They've written it in kind of a way to maybe, I don't know, just to make you feel like it's crazier, but that's what it is. And again, there's my y-intercept of +3. My slope is -6. Rise, -6. Run, hang on, so then I'd run 1 like that. So hang on, let me erase that dot. Go down 6, go over 1. So there's my graph like that. Again, x and f of x, or x and y. And if I plug in 0, I get 3. If I plug in 1, I get -3. If I plug in 2, I get, let's see, -9. All right, function c of x equals 25x plus 50 represents the labor costs in dollars for contractor A to build a deck. So this right here is our cost for contractor A to build a deck. And so I should write that the cost. That's what C is, right? Okay, great. And then X is the number of hours of labor. Now, I'm going to caution you. I stopped reading after dollars because I thought, oh, okay, X is dollars. You got to read the whole problem, right? Or else you're going to be a little confused. So now, the table shows sample labor costs from its main competitor, contractor B. The deck is estimated to take 8 hours. Which contractor would you hire? Okay. So this is B. This is A. Okay? And we aren't given any info to get us to 8 hours. Well, we're not given 8 hours for B. However, we can figure that out. This is going up by 2, up by 2. So obviously we can go up by 2 and comfortably make this jump, right? This is up by 30, this is up by 30, so this is up by 30. So we think the contractor B would cost $220 for 8 hours. Well, how about contractor A? 25, so what we're gonna do is cost for 8 hours equals 25 times 8 plus 50. Well, 25 times 8, that's 200, plus 50, he costs 250. So it seems like we are going to choose contractor B. Let f and g be functions. Use each statement to find a point on the graph of the functions. F of 5 is equal to 9. So the coordinates are going to be 5, 9. This is our x. And they're saying that f of 5 is 9. So we would write it like this. And that's why we're able to say that right there. A solution to the equation g of n equals -3 is 5. Okay, so that is worded in a fun manner. They're saying, hey, g of n equals -3, but currently, do you know what n is that would make this be our answer? As far as I know, it's 5. I shouldn't say as far as I know. What they're trying to tell us is that it's 5. So how we're going to answer this is we often write g of x because x is our input, and then this is going to be equal to y. It is our output. So what we're going to do is this is our output, and this is our input. The function A represents the attendance at a high school since the beginning of a flu outbreak. The graph of the function is shown. What happens to the school's attendance after the flu outbreak? Well, it would appear that after the flu outbreak, it goes down, and then it starts to go back up. So it decreases rapidly, then increases slowly. And if you're a little confused on how that is, I mean, doesn't it appear to decrease kind of quickly? I mean, here would be a slow decrease, or slower, I guess you could say. And then it just says estimate A of 13. So that would mean we're going to go look here at 13 and say that it's roughly right there. And if, let me erase my other line, maybe it'll be a little more helpful. So reason I did the dots there is because, well, this is 14, and so 13 would be kind of in the middle. So right about there, that is about, 425. So, and it gives us little choices. 425 works perfectly. The meaning of that is 13 weeks after the outbreak, the attendance is about up to 425 again. Use the graph to estimate the solution of the equation A of x equals 400. So basically they want to know about when do we think it's going to be at 400. And there's actually two answers for that. So one, I would say that happens at about week 1 right here, right? And the other is at week 10 right here. So that's us here, 1 and 10. And then I know it says explain the meanings for that. So the meaning is, after 1 week, we're down to 400. But then if you think of it, after 10 weeks, we are up to 400. So I guess you could squeeze that in there. After 1 week, we're down 400. After 10 weeks, we're up 400. What is the least attendance? And when did that occur? The least is going to be right here at 4 weeks. Looks like it's 350. Do we got choices for that? We do. The least attendance was 350 students, and that was 4 weeks after the flu outbreak. How many students do you think are enrolled at this high school? I would say more than 450, right? Because there's the number right there, and 450 is right there. So maybe 460. Well, do we have answer choices? I don't know if we have answer choices. Let me scroll on my thing. Okay, yeah, I see that about 460 is an answer choice. And then if we explain it, it's basically the highest point on the graph. And we have to estimate because it doesn't give us a perfect answer. So, there we go. All right, if you're here now, you probably are here because you saw my warnings that I screwed this problem up. I know, a mistake. I can't help it. I just got to make a mistake every now and then, even though I never really make mistakes anyway. Jokes landed. I thought the book would be nice to us, and it would definitely not give us a problem where it says both kilometers and miles in the same one, but it did. So if you're curious, here's what's going on. They gave us this in kilometers and this in miles. Okay, well, here's how you convert. I mean, you just multiply. So 91.4, you technically multiply it depending on how accurate you want to be. 1 mile is 1.60934 kilometers. So let me grab my calculator. That is 147.093676. Okay, so I mean, the reason that's, I guess we kind of keep this isn't just 147 point whatever. It's because this was 91,400,000, right? So really, we do this. We're going to go 1, 2, 3, 4, 5, 6 decimal places. 1, 2, 3, 4, 5, 6. Oh, look. That is exactly how many miles or kilometers, I suppose it is, right? So now let's convert it for the other end. 94.5 times 1.60934, and here's what we get. 152.08263. All right. So that, like I said, is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, is that right? Yeah, let me count that one more time. Yeah, that's right. So, okay. So how long does it take light to travel from the sun to Earth? We're just going to take this and divide it by 300,000. Take that, divide it by 300,000. So let me do that. Well, it would appear that now I'm too accurate because this ends up being 490.3, and because you round to the nearest tenth, and this one would be 506.9, and again, I've rounded. Apparently, I've been too accurate, so let me just tell you the answers. The answers are 491.4 for the first answer, and 508.1 for the second answer. Not really sure how this one is bigger, and so is this one, but whatever. Those are the answers. Have fun.